Hello, my name is Sriram. I am the software architect for Prosser SDK. Now that we have downloaded and installed the Prosser SDK, let us now see how you can get started with using the installed Linux and the RTOS SDKs. We will start with a brief summary of the various components that make up the SDK and details on where to find them once you have the SDK installed. We will then learn how to set up the build environment so that you can modify and rebuild specific components or demos as necessary. Finally, we will conclude with steps to run the demo on the Jacinto 7 EVM. Let us now take a closer look at the contents of the Prosser SDK Linux package. To reiterate, the Prosser SDK Linux runs on the Cortex-A cores on Jacinto 7 platform and provides the foundational building blocks to enable rapid application development. Prosser SDK Linux builds on a layered architecture to provide software entitlement primarily built around Linux and Linux compatible components. For most of the components, the source code is included under the board support folder. We will now look at specific components that are included within the SDK. At the bottommost layer, we have ATF or ARM Trusted Firmware, which is a port of ARM's community project. ATF provides a reference implementation for secure world software running on ARM v8 architectures. We then have the bootloader, U-Boot in this case. U-Boot supports a two-stage bootup process, a minimal first stage, followed by a more feature-rich second stage bootloader. U-Boot includes separate configurations for building each of the two stages. Normal development workflow will leverage both stages of the bootloader, while for a more optimized production boot flow, one or both stages could potentially be bypassed. Prosser SDK Linux package also includes a static partitioning hypervisor in the form of Jailhouse. This can be used to partition the system into independent domains that can then be mapped and used from independent virtual machine instances. The Prosser SDK includes illustration of one such configuration running two virtual machine instances, both the instances actually running Linux as an operating system. We then get into the next layer, the operating system, or Linux in this case. Linux support in the SDK is based on the community supported LTS or long-term stable kernel releases. With this working model, SDK releases will undergo migration to the latest LTS kernel every year. Source code for Linux can be found under a separate folder which includes the kernel and drivers for most of the peripherals supported on Jacinto 7. Some of the peripherals include drivers that are hosted outside the kernel tree. The graphics module and video encode decode modules are specific examples that are supported through out of the kernel tree drivers. Inter-processor communication is supported using RpMessage and remote proc modules under the Linux kernel. Likewise, peripheral drivers for connectivity modules like PCI, Ethernet, I2C, UART, and storage peripherals like MMC, UFS are included as standard drivers under Linux. SDK includes a pre-built root file system and necessary scripts and configuration recipes to rebuild the root file system using Yocto. As part of the SDK installation, the host environment for cross-compilation is set up, and the corresponding dependencies are bundled and made available under Linux DevKit folder. Lastly, Prosser SDK Linux relies on a GCC compiler, and one needs to download a 32-bit and the 64-bit toolchain versions following the links that are included in the SDK download page. Important note, PSDK includes pre-built binary for the Ethernet switch firmware. Source code for the Ethernet firmware, demos, and likewise the OpenVX component are included as part of the PSDK RA package. Now let's look at how to set up the build environment so that you can modify and rebuild SDK components. Steps for setting up the host environment and component level build are summarized under the Quick Start Guide section on the SDK documentation landing page. Once the SDK is downloaded and installed, follow steps described under setting up the host environment section of the user guide. Start by running the SDK install script. This is a one-time step and will extract and populate contents under the Linux DevKit folder. By default, this installs the 64-bit toolchain version. If both 32-bit and 64-bit toolchains are required, download and install following links from the SDK download page. Then run setup.sh. This will verify any host side dependencies, install required host side packages, and sets up the environment for root file system, NFS TFTP exports, and a number of other useful utilities. We now look at how to rebuild specific SDK components. SDK includes Makefile based build system for selectively rebuilding one or more SDK components. This comes in handy when only a specific component is modified, hence needs to be rebuilt. As a first step, ensure that the required host packages for the Makefile based build system are installed. Following this, ensure that the default path is updated to point to the location where the cost compilation toolchain is installed. With this step, we are now ready to rebuild components using the Makefile based build system. From the top level folder of the SDK installation, the Makefile can be invoked to build specific SDK components. Most of the foundational components like the kernel, U-boot, JLOS hypervisor are supported as Makefile targets. You can use the autocomplete feature to see a list of supported targets. SDK also includes Yocto recipes for the full SDK build, including the root file system. For specific instructions on Yocto build setup, refer to the corresponding section in the user guide. Typical development workflow will involve updates to a specific component. For example, updates to a kernel configuration or a device tree configuration. For these, the Makefile based component level build can be leveraged. Usage of Yocto requires additional expertise and is better leveraged for file system build or the full SDK build. We now look at the steps for preparing and running the out-of-the-box binaries. SDK package includes pre-built binaries for the boot images and the root file system. You can use the mksd boot script to partition the SD card and populate it with the pre-built file system and boot images. Once the card is created, it can be used to launch the Linux kernel using the SD card boot mode on the Jacinto 7 EVM. With this, you should be able to boot to the Linux prompt and also see the wallpaper show up on the EVM's DisplayPort. With that, we'll now switch context and focus on the Prosser SDK RTOS package. Let us now take a closer look at the contents of the Prosser SDK RTOS package. RTOS SDK package follows a modular approach and most SDK components are placed under respective component level subfolders. To start with, RTOS SDK is built on top of SysBIOS as the operating system. This runs on the R5F core and the C7X, C6X DSPs. TI's bare metal bootloader, system firmware binaries, inter-processor communication library, and various peripheral drivers are included as part of the PDK component. Then we have the Ethernet switch firmware running on the R5F core that manages the integrated Ethernet switch on the Jacinto 7 platform. Switch firmware is responsible for configuration of the switch and enables clients running from various other CPU cores to directly send receive traffic through the switch. Computer vision and deep learning libraries that are hardware accelerated are included as separate components under the RTOS SDK. OpenVX enables flexible graph pipelining based approach for realizing vision and compute applications, leveraging the heterogeneous architecture and the accelerator cores on the Jacinto 7 platform. TI's implementation of the OpenVX standard is included under the TI OVX component. Software that runs on the safety MCU island, namely MCAL support for AutoSAR and demos for early CAN response, safety entitlement are included as part of the MCU software component. Vision Apps folder hosts multiple demos that integrate various components from the SDK to realize system applications for vision processing like the surround view application and Auto Valet Park Assist. Also included under Vision Apps folder are basic demos that can be used for quick hardware checkout or as a starting point for other application development. Gateway Demos component includes an illustration for the CAN Ethernet bridging application. In addition to the contents of the SDK package, additional tools like the GCC compiler need to be downloaded separately. Please refer to the user guide for details on setting up the host development environment. Now let's look at the steps to set up the build environment, build and run out-of-the-box demos on the Jacinto 7 EVM. Build and run instructions are included as part of the Vision Apps user guide. You can navigate to this from the top-level PSDK array documentation link. As a first step, the host side build environment needs to be set up. Follow instructions described under the build environment setup section of the user guide. Once the build environment is set up, you can use the makefile based build mechanism to build the SDK or specific components. Steps for building the SDK, including supported build configurations, makefile options, are described under the build instructions section of the user guide. Lastly, steps to prepare the SD card with the build binaries and running the SDK demos are described under the run instructions section of the user guide. With this, we have successfully completed the training session on Processor SDK Automotive for a Jacinto 7 platform. As part of this training, we looked at steps for downloading and installing the Linux and RTOS SDK packages. We then delved into various components that constitute the SDK and steps for building the individual components and running the out-of-the-box demos. Included as part of the slide are other useful links related to the Processor SDK, links for the SDK package download, links for SDK documentation, and E2E support forum link for any further clarifications. Thanks for your time in going through this Getting Started with Processor SDK Automotive training video.